When you pull something new off the rack or out of your closet and you think about where it came from, you probably think about the brand. But do you ever think about where those clothes are actually manufactured? What you might not know is that environment, social, and governance factors are of increasing concern in the fashion industry. Fashion supply chains account for over 10% of global carbon emissions and 20% of global plastic production. In addition to that, forced and child labor are rampant throughout many of these factories. However, it's very difficult to create overarching policies at the company level to ensure that these issues are mitigated. All of these issues indicate that there is a need for a concise metric to explain ESG within the fashion industry. Major fashion companies are starting to integrate ESG policies into their practices. For example, H&M has recently released detailed supplier information, which is a level of transparency not seen by large companies in retail. Despite this, H&M fails to make binding commitments to actually ensure that their suppliers adhere to these policies. There is a clear interest in improving ESG within the fashion industry. 44.5% of companies claim to conduct broad risk assessments of their supply chains. However, only 7.6% of them actually identify critical suppliers in their supply chains to improve their overall ESG. So, despite this interest, there's a clear lack of transparency in the supply chain.
There are a few issues with current solutions. Current ESG metrics are often self-assessments at the supplier level, which allows factories to introduce bias by manipulating their own data. These reviews are often qualitative and descriptive, making them difficult to scale and compare across brands and products. While there are some external solutions, they're at the company level, not at the supplier level, where manufacturing and therefore violations actually take place. This is where ecoScore comes in. Our solution is to devise a holistic numerical scoring methodology, executed externally to decrease bias and enhance comparability. We design our solution specifically to combat the current problems. First, our data is US import data and external verified certification data from Sourcing Playground, a startup that we're working with. Second, our data is at the supplier level, not at the overall brand level. We then input this data into unsupervised machine learning and regression models, outputting a score from 0 to 100 for each factory. This is ecoScore, a unique deliverable for Sourcing Playground. ecoScore will provide value to three key stakeholders. First, fashion companies. In an increasingly strict regulatory environment and with rising consumer pressure, fashion companies must understand their supply chains and monitor them to pinpoint weak suppliers they may want to switch away from. Second, investors. It's been shown that ESG investing leads to higher equity returns and lower downside risk. Therefore, it's in investors' best interest to use ecoScore as a proxy for ESG risk when assessing target companies or monitoring their current portfolios. Finally, consumers. The Wharton School's Baker Retailing Center has shown that 2/3 of consumers would be willing to pay extra for sustainable goods. Consumers can use a company's average ecoScore to inform their buying decisions as well as to hold their favorite brands accountable on ESG metrics. This brings us to our design process. In August, we received our data from Sourcing Playground, which we spent the fall visualizing, exploring, and running introductory models on. Our key takeaway is that our data is unlabeled, meaning we would need to use unsupervised learning methods. Because of this, our final method first uses two unsupervised methods, FAMD dimensionality reduction as well as k-means clustering, followed by a scoring optimization regression function. This outputs our scores from 0 to 100, which we then display on our UI and will live permanently on Sourcing Playground's website.
So you might be wondering, why unsupervised machine learning? There are two distinct reasons. First, with so many suppliers and factories out there, we can't rely on people to be able to find the patterns in the data to create accurate scores. Machine learning models are able to find patterns within large data sets in ways that we as humans can't find. Additionally, unsupervised machine learning in particular is used for data sets that already aren't labeled. This means that without reliable ESG scores to compare our data against, we can't actually use a supervised machine learning model. Thus, we use unsupervised machine learning to get these patterns and actually extract scores from them. Let's look a little further into our model and its results. In order to actually use our model, we had to pre-process our data so that it was in the form required as an input for the model. Our data came in a nested format, which is incredibly difficult to work with, and additionally, it was categorical. Both nested and categorical data are not commonly used in most machine learning models. Therefore, we unnested our data and ended up with a very high dimensional data set. This data included country, product type, and certification criteria. Certification criteria are the unpacked requirements from all of the different certifications that companies provide to suppliers. With this, we ended up with 26 features. At such a high dimension, we can't actually understand what is happening in the data. Therefore, we conducted what's called dimensionality reduction. Dimensionality reduction takes all of our high-dimensional data and reduces it to a lower dimension by condensing the data into components that find specifically where the most variance is in our data set. We used factor analysis for mixed data types, a dimensionality reduction technique used on both quantitative and qualitative data sets, which is what our data set is, to find these patterns and to reduce our data. We ended up with over 50% of the variance explained in the first 3 components. So now that our data is in a lower dimension, from 26 features down to 3, we can actually visualize it. We chose to cluster on our dataset, and we can very easily see that in the first 2 dimensions. 4 clear clusters form. After finding 4 distinct clusters, we bring these clusters back to our original dataset to better understand what they mean. Looking at the clusters as they align with certification criteria, we see that our best cluster fulfills nearly all criteria, while our worst cluster fulfills nearly none of the criteria. However, while dimensionality reduction and clustering help us better interpret our dataset, this doesn't actually give us the score that we need. Therefore, we use our transform data from our FAMD output and plug that into an optimization function to get actual numerical scores for rating suppliers. This optimization function uses ordinary least squares regression with certification count as our metric for error. With statistically significant coefficients, we find an actual scoring function from our FAMD transform data. Looking at our scores over our FAMD output, we see a strong connection between the first principal component in that transform dataset and our actual score values, which have our best scores in yellow and our worst scores in purple. Now that we have these scores, let's look at it from an industry perspective. Looking at Company X with 3 suppliers, a worst, a middle, and a best supplier with scores of 2, 22, and nearly 100 respectively, there are a few key takeaways. First of all, our highest scoring suppliers fulfill nearly all of the certification criteria across all 3 ESG factors. Our lowest scoring supplier may be replaced by Company X with a better supplier that produces the same products at a higher score. Finally, Company X can compare itself to another company, such as Company Y, and see that its own supplier score distribution is much lower than that of Company Y's. Company Y's is much more uniform and higher distributed, and Company X may realize that they need to change a few of their suppliers or a lot of their suppliers in order to improve and act as a better competitor in terms of ESG metrics with Company Y.
While our scores will ultimately live on Sourcing Playground's website, we wanted to create our own UI to allow users to easily visualize ecoScores. For our platform, you can either search for clients or suppliers by filtering on numerous criteria. For example, let's say we wanted to look at all suppliers that Adidas uses in China. We can then enter Adidas in China as our criteria, and now once we click the search button, we'll get back all of our results. So here you can see all of the suppliers that Adidas uses in China. You can see that products that they create, the countries that they're in, and most importantly, their ecoScore. Beyond our project's social impact, we think that there's a strong commercial potential. If we were able to obtain 20% of large US fashion retailers, that would give us over 9,000 customers, which at an average monthly contract of $1,000 a month would leave us with an $114 million annual obtainable market. Our model is a great starting point for future iterations. Some limitations of our current model include data availability and verification. We plan to obtain additional data, such as non-compliance reports and dates on which certifications were obtained to further improve the reliability of our model. In addition, to tackle the problem of verification, since there are no known scores, we plan to work with different experts in order to verify our model.
This is ecoScore.